distribute x to the fourth plus x to the third y equals 6xy squared minus y cubed. And when I differentiate, I make sure that I keep in mind that y is a function of x. If you have any difficulties with that, put a little dot underneath it so you don't forget. So this is 4x to the third plus 3x squared y plus x cubed times dy over dx equals product rule 6y squared plus 6x times 2 times y times dy over dx minus 3 times y squared times dy over dx. So let's go back slowly. X to the fourth prime is 4x cubed. This is the product rule. 3x squared times the second function plus x cubed times the second function prime equals product rule. First function prime is 6 times the second one plus 6x times, I differentiate y squared, 2 times y times dy over dx. And now I'm here with y cubed, 3 times y squared, bring down 3, subtract 1 from the power times the inner function prime. Any questions so far before we continue? So now we are after this. So all terms that have the variable have to be on one side. So this one has to go to the other side, to the right, to be together with these two. And this one has to be separated from them to go to the other side. So then, what do we have here? I'm on page 4. So I have 4x cubed plus 3x squared y minus 6y squared equals. I start with this, 12xy minus x cubed and minus 3y squared, everything multiplied by dy over dx. So this term is positive on the left, it will become negative on the right. This is 12xy, and this is negative 3y squared. This is what I'm after. Since it multiplies this number, expression, whatever you want to call it, this will be this over this. So then dy over dx is 4x cubed plus 3x squared y minus 6y squared over 12xy minus x cubed minus 3y squared. And there is nothing we can do here to further simplify. There are no common factors. Don't try to do anything else here. It would be wrong. How is this? Any questions on any of the steps?
No, that was good. Thank you.
Thank you. Perfect. Next question. Anything you have from anything, WebAssign or anything else? If not, I will choose. So we need help with anything else? Anyone, please? Anything else?
I had a question.
Yes, I'm ready. Yes.
It was out of 5 point. Oh no, this is the wrong section. It was out of anti-derivatives 4.9.
Yes.
It was question 11.
Yes. Number 11.
Yeah, it says find f prime x equals in the numerator 3 in the denominator square root 1 minus x squared, comma, like this is separate. It says f 1/2 in parentheses equals 9.
Perfect. So we're asked to find, since we are given f prime, we have to use the notation f of x. When we are given the notation f of x, we have to use the notation uppercase f of x. We know this from fundamental theorem of calculus. But if we are given f prime, we have to use the notation f of x. So the question is, which function prime is 1 over the square root of 1 minus x squared? Anyone? Which function I differentiate to get 1 over the square root of 1 minus x squared?
Arc sine.
Yes. Thank you very much. Thank you very much. Plus a constant c. Now we are given this information. This is f of 1/2 equals 9. So 9 equals 3 arc sine of 1/2 plus a constant c. When x is 1/2, y is 9. Now we have to remember which angle has sine. So this is an angle. Which angle has sine 1/2? It's the nicest and the smallest one.
5/6.
Thank you. So we have now that 9 equals 3 times pi over 6 plus a constant c. We will simplify by 3. So then c is 9 minus pi over 2. We have to enter our c back in the function. So then f of x is now one unique function, arc sine x plus 9 minus pi over 2. This is the only function that passes through this point, 1/2 comma 9, and has this derivative. This is not a family of functions because the condition helped us determine a unique c. Unique, just one. Very good problem, thank you. Any questions on this? Good, next question. Next question, please. Anything?
Could we do
Yes.
a problem from 2.7?
Yes, ready.
Yeah. It was one of the homeworks, number 26. F of x is equal to x over 1 minus 4x. And I think we were finding the limit as h approaches 0.
So we want to find f prime of x
Yeah.
with a definition. Yes. So perfect. So this is the limit. So as we know, the derivative consists of the limit of the difference quotient, f of x plus h minus f of x divided by h. Perfect. So we can also now, we should always do that, if you're asked to find the derivative using the definition of the derivative, the limit of the difference quotient, you should always at the end find f prime with rules to check the answer. Don't say the answer is x over x plus 1 squared without checking it with the rules, because you know how, right? Let me remove this from here so it doesn't confuse anyone. What will I do without whiteout? I don't know. I hope we never run out. Okay, so I will put f of x plus h here. I will copy the function and then continue with the limit as h approaches 0. Limit. Please do not drop the limit operator till you apply it. Please, I'm begging you, so you don't lose points for nothing. For nothing. Okay? Do not drop the limit operator till the end. So we have x plus h over 1 minus 4x minus 4h minus x over 1 minus 4x divided by h. This is not a friendly situation because of these, the function is not nice, so to speak. Okay, let me see the time here. Oh, I'm still fine. Okay. So limit sh approaches 0. You have to remember how to find the least common denominator. These two have no common factors. It has to be the product of the two. So I have h, 1 minus 4x, and 1 minus 4x minus 4h. Because this is h over 1, and I already flipped it. But now you have to be very careful because the x plus h needs to be multiplied by what it does not have. And the top x has to be multiplied by what it does not have, 1 minus 4x minus 4h. This is not a fraction line, remember. This is just a reminder for myself. If you like to use this method, use this method. If you want a different method, I'm fine with it. But this is a reminder telling me that I have to multiply x plus h by this, and I have to distribute x to these three terms. And be careful with the negative in front. So x distributed to these two pieces. Watch me run out of room. X minus, I'm going to try and be mindful of that. So x minus 4x squared plus h and minus 4xh. Okay, maybe I will not run out of room this time. Minus x, but plus 4x squared and also plus 4xh. At this point, you know what has to happen. All terms without h have to go away, and eventually this h has to simplify with an h from the top. Okay, so let's see. The negative x with a positive x. The positive 4x squared with a negative 4x squared. The positive 4xh with a negative 4xh. So what is left at the top is just h. That will go away with this, but not now. Write it one more time. Let's be safe. Limit, don't drop the limit operator. We have not applied it yet. Now you show that you simplify these two, and now you can already apply the limit operator. This is the only term that goes away. When h approaches 0, this is the only one that goes away. So the answer is 1 over 1 minus 4x squared. Do I know whether I made an error or here? No, I don't. But it's very simple. I'll use the rules now to check my work. Top prime is 1 minus top times the denominator prime over the denominator squared. So this is negative 4x, and this is positive 4x, so I know that I'm okay. Yes.
I have a question. So every time we solve this problem, do we always have to check at the bottom, or?
No, but if you write something that doesn't make any sense, then you lose points.
And check, yeah.
You don't have to. I want to. I want to make sure that I always check my work. It doesn't mean that I'm teaching you to doubt yourselves. No, I'm teaching you to be safe. Say, is this true? What if I made a blah, 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 something there? I use the rules. It takes, the problem may even ask you to. Now check with rules. Ah, I see that, I see that. So the problem may even ask you, okay, check with rules. Whatever you got, you have to get the same thing. But if I have here 2 over 1 minus 4x squared, and I only get with rules 1, I'll say, oops, something is wrong. They have to be identical.
Could you scroll back up on the paper again, please?
Sure.
Okay, could you go back down? Sorry.
No worries.
So wait, I'm a bit confused. So for where you got the numerator from, so just, oh, okay, never mind.
You mean this numerator?
No, when you checked it, the process of checking it.
Ah,
Yeah.
So the first function prime is 1 times the denominator minus the first function times the
Oh.
denominator prime,
Okay.
the quotient rule. So 1 minus 4x plus 4x, these two go away. So that's how I get the 1.
Okay. Okay.
Better?
Yes. Thank you.
Thank you. I don't know what's going on here. Why am I not? Okay. Good. Next question, please. Anything else you'd like to work on or you need help with? Anything?
If no one else has one, I have one from 3.9 related rates from the web assign.
Yes.
I'm sorry again, but you would have to look this one up too. It's another word problem. I believe it's number 4 from 3.9.
Oh, I forgot to mention if this problem. So did you? Oh, I'm sorry. Did you have the same numbers on the problem we worked on? Or did you have
Yeah,
some?
from the earlier one, yes.
Oh, okay. Okay. Good. Good. I should
Thank
have
you.
asked because they're different. So you want number 4 here.
Yes.
Okay. Perfect. Now, if you want to change the 4 or if you want to change the 45, we can do that. Whatever you want. Do you have 4 feet per second and 45 feet?
No, but we can go through that. I just need to see the process.
Okay, fine.
Not really the same answer. I just want to understand.
Perfect. Awesome. So a street light is mounted at the top of a 15-foot tall pole. Okay. That's all I know from the first sentence. A man 6 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. So he's 6 feet tall, 4 feet per second. I'm sorry, but I cannot draw a person. Okay, so this person walks away at 4 feet per second. So first of all, I have to say that this is the x covered already. And this must be the dx over dt because it's the speed at which he goes away, moves away from the pole. So this is the distance that he already covered. He started here, he moves this in this direction. So this is x, and 4 feet per second is dx over dt. That's what I know from the first 2 sentences. And then I'm going to read it again to make sure that I took care of everything. How fast in feet per second is the tip of his shadow moving when he is, you know that this is the trap, when he is 45 feet from the pole. So here's what happens. So when he is at x, this is the instant with the tip of the shadow. Now when he is here, he doesn't seem like he's going this way. He's like, I'm sorry, I just can't draw a person. I'm sorry. Okay. Okay. So here's what happens. So when he's here, the tip of his shadow is here. When he is at this position, so this is x now, the tip of the shadow is here. So we are asked to find, talk about this. So one more time. So he's wondering, okay, that's clear. A man 6 feet tall walks away from the pole with a speed of 4 feet per second along the straight path. Fine. How fast in feet per second is the tip of his shadow moving when he is 45 feet from the pole? So I'm going to call this W. So we want to find dW over dt when x is 45 feet. This is our question. And of course, we know that this is the trap. I can't plug in if I don't have W and I don't have it differentiated, and then I can plug in. So this means nothing. I have to find W, and I have to find the derivative of W, and then I plug it in. I'm looking at the time. Okay, let me